Hi everyone. So next we want to discuss what are these variables are polynomial time to 1 and polynomial time to 2. So to see this, at first you can type polynomial time 2. Then you can see exactly what are these variables. So the first variable is here and second variable is here. So we define first variable as x1 and second variable as x2. Then you can make the matrix plot of this. Then the graph is here. So maybe we can add x-axis. Then you can see the first variable is the straight line which goes through 0 at x is equal to 50. So at the center, it goes through the y is equal to 0, and this is straight line. And the second, the polynomial is actually the quadratic polynomial, which is orthogonal to this first polynomial. In this way, the multi-collinearity, the problem can be removed, and we can fit just orthogonal to variables. So we have the small enough, the standard error for each coefficient. So actually, this polynomial function does not fit just y on x and x squared, but we choose the two orthogonal polynomial. First one is linear and the second one is quadratic. So if we take correlation coefficient of x1 and x2, so this is almost 0. Actually, this should be exactly 0 theoretically. So if you want to get the same output as this one, actually, if you put this first variable and this second variable, that you can exactly get the same result. So you can see if we put maybe lm2b as lm of nile on this x1 and x2, then if we output this result, then these coefficients coincide with original regression result of this 919 and negative 783 and 558, 56. So how about when we want to fit y on exactly intercept and x squared? Then we have this option in the polynomial function. So that is another way to fit the model. So lm2r is equal to lm nile on polynomial of time with degree 2 and RAW rho is equal to true. Then you can get summary of this. So now the first variable and the second variable, so these are actually just the time itself and the square of time. So you can compare the coefficients and the t-values. So here the t-values are negative 4 and the positive 3.96. So if we compare this with previous result, actually the t-value is somewhat smaller. This is because we have some multi-collinearity between this first and second predictors at this time. So this is exactly the same as fitting y on time and square of time. To put square of time in regression model in R, we have to put this I parenthesis. Then you can exactly get the same results. So now we understood how this polynomial regression works. So at first, if without any option, so this function uses orthogonal basis. So polynomial of 1 and polynomial of 2 are orthogonal. But if we specify the option rho is equal to t, then we simply fit y on x and x squared. Okay, so see you then.